All right, so howdy, my name's Eric, and I'm going to talk a little bit today about instrumenting the rest of the company, and looking for useful metrics. Alternatively, this title is called Lies, Damned Lies, and Hacky Scripts. A little bit about me, I've worked at a whole bunch of different companies. Apparently I can only work at companies that have a green word mark for a name. But slightly more useful is that I've jumped back and forth a whole bunch between being an individual contributor and being a manager. And one of the weird things, this also a slide, is why I can't tell what I want to do when I grow up. One of the things that I noticed when I first switched from being an engineer to being a manager was that I spent a lot more time in meetings. But beyond spending more time in meetings, I'd spend more time in meetings with people who weren't quite as metrics inclined as everyone in this room. I'd spend time in meetings with sales folks and with marketing, and I hear this common pattern over and over. And it went something like this. We have a problem, foo, so we're going to do bar. And it would literally just kind of be thrown out as an assertion of fact. And this was kind of nerd sniping for the engineer in me, because I would immediately go, wait, how do you know? What data did you know? How did you find out that foo is a problem? How do you know about this? And if you do bar, how are you going to measure that it's actually going to change anything? And I'd kind of get this response that would sound an awful lot like Charlie Brown's teacher noise of womp, 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 womp. Well, we really can't actually measure either foo or bar. I'd hear this high-pitched noise in the back of my head that I was pretty sure was Demings doing 5,400 RPM in his grave. Because without data, you're just another person with an opinion. And a lot of meetings I would be in, I would just be like, we're just arguing about each other's opinions and not actually facts. And I'm an engineer. I like solving problems. So I'm going to go out and I'm going to start to write code. Even though I'm a manager now, I've got that engineering background. And so over time, I would just show up at the next meeting with facts or like, here's what I found out. And over and over, I would do this, and then people learned to nerd snipe me into doing their work for them. But I started to have this collection of shell scripts, or Ruby scripts, or Perl scripts, or whatever at the time, and I would keep this on my local laptop. And I actually started to get I felt bad about this. I'm like, I'm being an engineer when I should be a manager. Apparently, I'm supposed to have arguments about opinions. I also like that apparently my naming scheme is more consistent than my choice of language. Apologies for the small font. And it turns out I talk with other engineering managers and they do this too. So the kind of first takeaway from this is that if you're looking for metrics, the odds are somebody else in your organization probably is too. So what I thought I'd do today is share 3 little stories about different ways I've gone hunting for instrumentation and telemetry in my companies that I've worked in, and hopefully you can take some of them back and maybe do them in your own organizations. So this first story here, was sitting there and was hearing about new folks coming on board, and I heard kind of a complaint. And it was, we have a problem with people not knowing what the chatbot does inside our company. So we're going to write better documentation. Wait a minute, this is a chatbot. Really? We use the chatbot to deploy. We use the chatbot to find out about, I have to aim that way. We use a chatbot to find out about the environment. We use a chatbot to converge chef. We use a chatbot to provision hardware. And apparently there's a lag. And really, we have to write things on Wiki that nobody else is ever going to read? What's actually going on here? Why are people finding it difficult to understand how to use the chatbot? Can we use Slack? Can Slack's metrics basically tell us maybe a little bit more? Are people getting confused? What's the instrumentation there? This is the grand total of what Slack gives you for statistics. That's probably a good thing because Slack is awesome in many other ways. But what we really need is we need to just grab the set of events and what's coming off this chatbot and record it, like a stream of events, and then show them on a graph. If only we had such a tool. So we did. What we did is we ended up writing a plugin to shove pretty much everything that we saw come across the bot framework into StatsD. And it's the same Datadog dashboards as we use for everything else in developing the product. So it's a convenient tool chain. It's already set up. The chatbot host already has StatsD for all these other reasons. So it's just one more set of data. And we started to dig into it. It's like, okay, cool. Here's when there's valid commands being sent. Here's when there's invalid commands being sent. Here's who's sending them. Here's what the syntax is when it works and when it doesn't work. Here's the most popular plugins. Here's the least popular plugins. Why are they least popular? Of course, what we also found out was that Lunch was one of the most popular plugins. Thousands and thousands of hours and lines of code to provision code and provision hosts, and Lunch is what's most popular. And so the outcome was that instead of writing documentation on a wiki that nobody was going to read, we were able to dig in and actually find out, oh, okay, here's the commands where somebody is having a problem or isn't getting the syntax quite right. Let's go fix that. And so it's a better experience for everybody involved. And our bot now has KPIs. Our bot actually now has basically, you should not have this many invalid messages sent to you, or you should have this many valid messages sent to you. And it's a way better way of thinking about internal tooling than just as, it's not working again, complaint. So reusing your existing metrics toolchain with other internal tools in your organization is useful and it can make sense. The second story came about, again, apologies for anybody who's ever run Jenkins or things like that. This can be a little sensitive. But sitting around engineers one day, and we have these slow tests. So what we're going to do is we're basically going to complain a lot about it. And I actually don't mean that as negatively as you might think. So the problem was that the engineers and everybody writing these tests or using the CI system, they didn't know what the problem was. Some people thought that it was the database fixtures framework. Some people thought that it was we were doing too many of a certain kind of test. Some people thought, well, our CI hosts are under provision, so we need to change to a different CI tool. And everybody just kind of kept taking random guesses and complaining about it. And so, okay, let's dig into this. Well, what's the first problem is you're saying that CI is too slow. Define slow, right? If I was to go to you and say the website's slow, one of the first things hopefully you'd ask is, what does slow actually mean to you? Is it 1 second? Is it 5 seconds? Some sort of a threshold, and get that baseline so that we know what to start comparing against. And it turned out that pretty much every engineer would run tests locally on their laptop, and if the CI system was any slower than what they were able to do on their laptop, then they started to complain. So, okay, cool. Let's go into the CI system and start grabbing the metrics. And lo and behold, the CI system didn't quite have the same good way of getting metrics. Let's use the same trick as before. Let's stick a script at the end of the CI, at the end of the test run, and let's grab timestamps all throughout, and let's just emit those back in as statsd. And we have kind of a complicated setup, so we're able to capture like the different build dimensions across a build matrix. Okay, yay, we get a pretty graph. And the pretty graph shows that tests are running and nobody was doing anything in the middle of there. But the problem is when we got the pretty graph and we got the instrumentation, it didn't show that the tests were that much slower. They were kind of creeping up there, but they weren't creeping up there anywhere near enough to be the problem. So a little bit of lag. So we dug into it and we're like, okay, so we've just had instrumentation now. We can show that the tests are taking about the same amount of time on CI as they are on your laptop. Broken down for build matrix and all that. And dug in further and it's like, oh, so what you're perceiving as the test being slow is actually the time that little dot goes from yellow to green on GitHub's pull request status. Oh, okay, so this is more along the lines of the tests are taking too long to start, or they're taking a variable amount of time to start. Okay, well, we can't actually grab timestamps from a script if the script hasn't started running yet. So let's go to the CI tool and see if it can start to give us some of the data from its API. Only problem is that its API didn't expose, this is a job queue waiting time, and the API didn't expose it. So once again, scripts to the rescue here. And this is a sort of script I actually found that somebody else had written the exact same copy of in the same company to answer the same question in a different way. And let's go emit those metrics into Datadog and start to dig into it. My apologies, I don't have quite a pretty graph here, but the outcome of digging into it and finding out how many jobs were being run and when the queue wait time was we have Scrum teams. Those Scrum teams work on 2-week sprints. Those 2-week sprints have ends, and they would all wait until the end of the end to merge their pull requests. This is actually a good thing, right? Because what we did is we found out, okay, our CI worker capacity needs to be related to the number of engineers, but we also got to have a conversation with the Agile coaches about, let's maybe have a conversation inside our Scrum teams about not all merging on the last day of the sprint. So the takeaway here is that there are metrics that you can grab, but you might need to kind of reverse engineer your way into them and find basically the overall metric and then kind of dig around to find the specific one inside it that you need to find, that you need to use. So for the third story here, so like I said, that question is about we're going to do foo because of bar. Well, sometimes you can't actually stop bar from happening. In this particular case, the engineering managers at this particular company and the senior leadership wanted to ship faster. And it was kind of recognized that the organization wasn't working right. So we're going to reorganize. Great. Not going to probably stop that. But everyone who's ever been through a reorganization has probably asked the question, why are we bothering with this? Or did this actually do any good? When we reorganized, did we actually do foo? Did we do that shipping of that code faster? And, well, this is what tools like Jira are for, right? Oh yeah, well, Jira will just show us the sprint burn down chart, and we'll have magic graphs that will go bottom to down and to the right. But I guess that's a good thing. The problem is, though, is that Jira and some of these productivity tracking tools, they're not actually showing where the bottlenecks are. They're showing the kind of overall team behavior and the team health, and they're valid. But if you're reorganizing and you're trying to find ways that every team can, say, own their own service and their own repo and be responsible for their own production hardware, you may not be able to capture all of that inside of these kinds of productivity tools. So what we did is we said, okay, what's the unit of change? What's actually shipping code faster mean? Well, it means pull requests. Pull requests stay open way too long. So if pull requests start to close in close in less time, then we're probably shipping faster. Problem is, again, GitHub doesn't show pull request length of pull request time fairly easily. So what we did is a little bit of overkill, but we piped GitHub metrics into, in this case, AWS Redshift and Mode Analytics, which is kind of a visualization tool. There's Looker, there's all sorts of other stuff. And it's a little bit of overkill, but the good part is that the BI team already knew about all of it. It wasn't introducing another new tool into the tool chain. So they are taking care of that GitHub data import. And it's one less thing that everybody has to worry about. So, okay, cool. Now we've got the data in a data warehouse, GitHub pull requests in a data warehouse, and you can use things like SQL. Okay, so now we've gone from, well, I really hope that pull requests answer faster, or even hacky shell scripts, to SQL that's just sitting there running in the rest of your business intelligence tools. And what we wanted to ask the question was, this dark green line here, right, this is median pull request open time, how long it stays open for. It's like over 20 days. It's like over almost 2 sprints. And the whole point is you're supposed to ship in less than 1. So let's go start making all of these organizational changes and having lots and lots of one-on-ones where everyone asks if this is really worth it. And then being able to show the graph. Yes, it's not just you. You're not just imagining things. Your pull requests are closing faster. And being able to show that across the whole organization. So it only took the outcome was productivity success. It only took a year's worth of pain and sweat to do it. So the takeaway here is that sometimes you aren't going to be able to instrument exactly what it is that you want to find out. Human beings don't have stats D endpoints yet, or hopefully ever. But you need to make sure that you can find those proxy metrics. Just be really, really careful and choose wisely, because sometimes you'll pick a proxy metric that might incentivize the wrong behavior. And a couple of little potpourri items here that I couldn't fit into any of the other stories. First one is that there's a lot of different ways that you can find this data and then start shipping it into a stats-D on a regular basis. Culling through chat logs, culling through your email. One of the more entertaining ones that I've seen is a former manager of mine has a script he runs every week that basically culls all of the calendars for everyone who reports to him and does a percentage time in meeting. And that's tracked, just like, and it's, you know, it's not like a thing that anyone's going to get docked for in their performance reviews, but it's tracked to be like, hey, I noticed you've been in a few more meetings than normal for the last couple months. How's everything going? It's another indicator of health, and it's easy to collect. Cross-validation of the metrics. I didn't quite show this earlier, but one of the graphs that I was going to kind of show was, we showed that the pull request time was going down, and then we were also able to show that in Jira that the sprint velocity kind of increased. So it's good to necessarily sometimes look at the different metrics to be able to cross-validate, hey, did we actually collect the data we think we collected, and is it behaving the way we think it is? The problem is when you start to think about metrics and metric behavior, this is a whole talk, but there are a whole series of cognitive biases around metrics that also can act like kind of combo modifiers and basically multiply on each other. So it's not just one cognitive bias, but a whole bunch chained together. And one last thing here's a problem I haven't really seen anybody solve yet, and I would love to hear if anybody has. Plotting against organization metrics. So when you hire additional people, like the overall number of engineers, like we saw earlier, plotting number of engineers versus number of CI workers, or revenue numbers or things like that, plotting against those can also be really helpful. So to kind of jump through my takeaways real quick, because I'm sure everybody wants lunch, useful metrics are everywhere. There's all sorts of data if you haven't gone looking for it. You aren't alone in digging for it. The existing toolchain, StatsD, is meant to be flexible. It's meant to be this flexible toolchain that you can put any metric into. This is just another kind of that data. You can reverse engineer and find proxy metrics for a lot of the questions you might want to ask. Thank you.